3.1 Part 2. This first page just goes to show how we're going to use compound interest and how the formula came about. But what you need to really understand is what the formula represents. This is going to be our final amount. P is our initial amount. 1 is always the number that's always there. R is our rate in decimal form. N is the number of times per year. So if you said biannually, you'd put a 2. If you said quarterly, you'd put a 4. If you said monthly, you'd put a 12. And those are the same. And then T is our time. How long does it take for something to happen? So as long as you know your components and you know your formula, and yes, you'll have to know your formula. It will not be given to you. You do need to memorize it. And we're just going to do a few examples using this formula. So here we have $9,000 invested. Invested means beginning. So that's P. At an annual interest rate of 8.5%. So there's our rate written as a decimal. Compounded annually. Annually means once. So that's our N. And find our balance after 3 years. There's our time. Plug it all into the formula. How much money, the balance afterwards. So how much money do we have if we invested $9,000? 1 plus the rate over how many times we do it. And then 1 times 3. This is nothing more than a calculator problem. So 9,000. 1 plus 0.085 divided by 1. We already know what that is. To the 3. And plug it into your calculator. Because it is money, make sure we label it appropriately and round to the nearest cents appropriately as well. All right, so here we have, we're going to do different ends. Okay, here we have 12,000 invested, so that's our P. Interest rate, so that's our R. 5 years, that's our T. Quarterly means N is 4. Monthly, N is 12. Here we're going to have a little bit different formula for continuously. So we're going to start that one and we're going to do that one last. All right, so here we have 12,000. 1 plus the percent over how many times, and then how many times T. Punch it all in your calculator. Make sure to round appropriately. And 18,726.11 hopefully is what you got. Do it again for monthly. So you start with $12,000. You have your percent rate. That didn't change, but the number of times you do it did. So that's 12. And 12 times 5 gives us the amount of money is $18,788.17. Notice that the amount of money isn't really that different compounded quarterly to monthly. It is a little bit different, and so that's why we do have, the formula for it, but it really isn't that much. When it comes to continuous is special. That's why it is highlighted. That's why it is starred, and that's why you need to highlight it and start it as well. Continuous does not use this exact formula. Continuous uses the formula A equals PERT. Okay. Again, A is final, P is initial, R is rate as a decimal, T is time. But E, we know, is a number. We just got that in 3.1 Part 1. E is a specific number. So in this case, I don't have to use my N's. My N is represented by E. And this only works for continuously. Continuously means E. Monthly, quarterly means our N's are different times per year. Continuously means E. So here we're going to get 12,000. E, R is still the same, and time is still the same. And in our calculator, we have an E button, so we use it. 12,000 E to the 0.09 times 5. And we get $18,819.75. So mark it, start, highlight it. Continuous is a different formula. It's the formula with E in it. And you will see that again. All right, radioactive decay. They give us a formula of what the decay is. They say the half-life is 25 years. So that's what this half comes from. The half is the half-life right here, half-life. The 25 comes from what's given in there. T is years. And then the 10 is actually our beginning amount. And you'll see why here in a minute. All right, when T is 0, so what is the initial mass when time started? So 10, 1/2, and then we get 0 over 25. Well, that's 10, 1/2 to the 0. Anything to the 0 is 1. So what was our initial mass? 10 grams. So that's why in our initial equation we know that's the initial amount, is because of the way that the equation is set up. But always plug in 0, and that also will be able to algebraically figure that out. So how much initial mass is present after 80 years? So how much is left of the 10 if the half-life is 80 years over 25. So all we did was change out the T for 80 over 25. That's a straight calculator problem. 10, 1/2 to the, use parentheses appropriately please, 80 divided by 25. We get, of the 10 grams, 1088 grams. And again, 3 decimal places is fine, just around appropriately. So that is using a new formula, whether it's about interest, compounding at a rate, or compounding continuously. And then we also have a decay formula. But basically it's about substituting and being able to use your calculator. And that is part 2.